Welcome all of you to the chemistry online classes. So, in today's class we are going to discuss about few more important bit of the topic, that is regarding the color of the transition metals. Okay, first of all we discussed about the crystal field theory, that is how the crystal field splitting, that is the d orbital will going to be split up in the T2z and Ez orbitals, how exactly it occurs when the ligands are different, when it is octahedral field, when it is tetrahedral field, what we did, that all the points are already explained. Okay. In case of octahedral, you can use the Ez upside, that is Ez orbital consisting of dx square minus y square and dz square orbitals, whereas T2z consider of dxy, dyz and dzx, that will be the lower side, and the crystal field splitting energy there we are going to represent in the way of delta naught in case of the octahedral. Okay, where in case of the tetrahedral exactly it is inverted, T2 level you should not use the G term in case of the tetrahedral, you can use only T2 and E terms, where we are representing this as a delta, and delta T is less than delta naught, which is known as delta T is equal to 4 by 9 times of the delta naught. Okay. So, all these are the points which we which we already discussed, and in our today's class we are going to discuss about the limitations of the crystal field theory. So, as you know, the crystal field theory explained about how that what we can say splitting will going to be takes place, what about its crystal field, that is stabilization energy will be there, that all explained, but certain drawbacks also there for the crystal field theory, which are those. See here, it cannot consider the covalent character of the metal ligand bonds. So, according to the crystal field theory, we cannot explain the metal ligand relationship, how covalent character is existing in it, that cannot be explained with the help of the crystal field theory. So, it is considered as a one of the drawback. Okay. And next one, it cannot, I have said you regarding the crystal field theory postulates or features, during that time we are considering it as electrostatic model, we are discussing about the point charges. Here the point is that even though, see here, it cannot explain why the negatively charged ligand, for example, which are negatively charged ligand like I minus, Br minus, F minus, Cl minus and so on. These are the weak ligand we considered here as a weak ligand, even though those act as a point negative charge. So, this is the point which cannot be explained with the help of the crystal field theory. So, there are two drawbacks we can say, that first one, the crystal field theory cannot explain the covalent character of the metal ligand bond, and the second point is that even though the negatively charged ligands like Br minus, I minus, Cl minus, those are act as a point negative charge, but we consider them as a weak ligand. So, what is the reason why it cannot be explained with the help of the crystal field theory, and those are further explained with the help of the some of the other theories, but for your syllabus they have kept only crystal field theory, so that we have finished. Okay. And in case of crystal field theory, first of all we discussed about the postulates, and we discussed about the how it will going to be splitting, what is crystal field splitting energy and what is crystal field splitting, how exactly the d orbitals undergo degeneration, how the ligand approaches towards it, and depending upon the approaching way, whether the ligand approaches in between the axis or along the axis, we are considering them as octahedral as well as tetrahedral, and the splitting, the orbital arrangement will be different for the different ligands, whether it is octahedral field or tetrahedral field, and this is about the drawback of the crystal field theory. So, let us discuss about the color of the coordination compounds. As you know, the transition metals exhibit the different property, like it is one of the very important property of the transition metal, that they exhibit the color, that only here we are going to discuss about the color of the coordination compounds. As you know, the coordination compounds also consisting of the D metal, that is the metals which are having the d orbitals. Suppose whenever I am passing a white light, whenever I am passing we are passing a white light to the complex, to the solution of the coordination complex, during that time what happens, certain what we can say, the electromagnetic radiation from the white light are absorbed by the solution of the coordination complex, and the color which is absorbed, that only, that complementary color is transmitted. Okay, the color which is absorbed, that will be transmitted, and the color which is absorbed and the color which is transmitted, those are said to be complementary colors. Okay, suppose see here, there is a complex, that is copper sulfate is the solution I am taking. This is, if you consider the solution of the transition metal, then I am passing a white light. Certain electromagnetic radiations of the white light is absorbed by this one. Certain electromagnetic radiation from the white light is absorbed by the solution of this transition metal. So what happens here, the red color is absorbed, and then which color is transmitted here, blue color is transmitted. That's why the copper sulfate, that is the copper salts, are blue in color. This is the reason. Red is absorbed, blue is transmitted. That's why red and blue are said to be a complementary color. Red and blue are said to be a complementary color. See here, I have given a list of the colors, the color which is absorbed here and the color which is transmitted here. Suppose the yellow color is absorbed from the white light, which color is transmitted? Violet color is transmitted, and the color of that complex will be violet itself. Okay, are you getting my point, what I am exactly explaining? See here, we are passing a white light. White light consisting of the different electromagnetic radiation, it consisting of, it may be, as you know, white light consisting of the 7 colors. In those colors, any one of the color like this, suppose it may be absorbed, it can absorb yellow, it can absorb blue green, it can absorb blue, it can absorb ultraviolet red, like this. If it absorb, so during that time what happens here, one of the color is transmitted. One of the color is transmitted. So we can say here that the transmitted color and the absorbed color are complementary with each other. Suppose yellow color is absorbed, then we are going to get the color of the complex as a violet, because it is transmitted. Because it is transmitted, so the color of the complex will be violet color. Next, if a blue-green color is absorbed, we are going to get the complementary color, that is the color of the complex will be red. And then suppose only blue is absorbed, we are going to get the complex color as a yellow-orange. Suppose if it is ultraviolet, pale yellow is absorbed. Similarly, all the colors which are absorbed, the complementary color will be the color of the complex. These two are said to be complementary colors. I hope so you are getting. Suppose let me clarify this this concept by taking one of the example. Okay, here hexa aqua titanium 3 is there. This is the complex ion they have given. See here, let me know how many electrons are there in its d orbital. So if you consider titanium, it is neutral ligand, directly I can say that titanium is in the form of titanium plus 3. How I have calculated titanium plus 3? You can go also. I need to know the state of this one, means I will take it as a x plus 6 into 0, because water is a neutral ligand, it can contribute 0, which is equivalent to the charge of the complex, that is plus 3. Therefore, x is equals to plus 3. X is equals to plus 3. So, titanium is in the form of plus 3. So, titanium plus 3 is there, means if you wrote the electronic configuration exactly for titanium, what will be the configuration? Titanium atomic number is 22. So, 1s2. Okay. Now it is 22. Just look at the outer orbital, titanium in the form of titanium plus 3. Titanium plus 3. So I will remove the outer electrons, 2 electrons from the S and 1 electron from the 3D. So it will be a 3D1 and 4S0. So how many electrons are there in the 3D orbital? 1 electron is there. So now you just look at the, it is a octahedral, it is a octahedral complex, 6 ligands are there. If octahedral complex is there, how the crystal field splitting will going to be occurs? Easy level will be upside. So what happens here? T2Z, this is T2Z. 3 orbitals will be there in case of T2Z, while 2 orbitals, this is dxy, dyz, dzx will be there, or dxz you can take, and this is dx square minus y square dz square. This is easy level. So now our electron is here, 3D1. So what happens? This is nothing but crystal field energy, that is delta naught. Now I am providing the energy h nu, it means I am passing a white light, I am providing the energy. So what happens? The electron absorbs the energy, so it can jump from T2Z level to the EZ level, so that the color of the transition metals can be observed. Okay. See here what happens. Here the electron is jumped. This transition is known as DD transition. This transition is known as DD transition. Okay. Whenever white light is passed to the solution of the complex, there is a excitement, there is a jumping of the electron will going to be takes place from lower energy level to the higher energy, or you can say that T2Z to EZ level. So what happens here? The configuration will be T2Z. In the T2Z orbital, how many electron? 1 electron is there. In case of EZ, it will be a 0. There is a transition of electron from this energy level to which energy level? Here T2Z will be 0 because no electron in the T2Z orbital. And in case of EZ, there that 1 electron is jumped there. So this transition from T2Z to EZ level is known as DD transition. Okay. So the color of the complex is mainly due to, why they will exhibit the color? Because the presence of ligand also matters. The presence of ligand also matters because the ligand can able to divide, or the ligand can able to split the d orbital. If d orbital splitting is not there, means we cannot explain about the jumping process. Yes or no? We cannot explain about the excitement. First there must be a splitting of the d orbital should takes place. That is done with the help of the ligand. When the ligand approaches towards the central metal atom, there is a splitting occurs. When there is a splitting, then there is a excitement. When there is a splitting occurs, during that time electron will be here only. When I am passing the energy of h nu quantity, that is we are passing the white light, and certain electromagnetic radiations are absorbed, that energy is transmitted to this electron. So there is a jumping of electron from T to Z, or you can say transition, it means changing its place. There is a transition from EZ, that is T to Z level to EZ level. This transition is known as DD transition. Let us discuss few more important points of the regarding the color of the transition metal. See here, as I said you, the presence of ligand is very important, because the ligand, suppose any complex is there, just you think any complex is there. See here, take this one only, this one, okay. Just you look at the complex. This is the central metal atom, this is the ligand. So when the ligand approaches towards the central metal atom, then only there is a splitting of the d orbital will going to be takes place. When there is a splitting of d orbital takes place, then only there is a possibility of dd transition. Yes or no? Then only there is a possibility of DD transition. So when the DD transition will going to be occur, the color is exhibited by the coordination complex. So that only few more points we want to discuss here. That is, just you look at here, in absence of a ligand, crystal field splitting does not occur or does not takes place in absence of a ligand. The crystal field splitting does not takes place, and hence the substance is colorless. If there is no crystal field splitting, if there is no splitting, there is no color. Those compounds are colorless, we can say. For example, you can take this one as a complex. Okay, see here, this complex, it consisting of the water, that is a ligand. Okay, so whenever this is heated, the water is get lost. When the water is lost, it becomes colorless, because the ligand, water is itself acts as a ligand. So the ligand is not there, means the splitting will not going to be takes place. So if there is no splitting, no DD transition. If there is no DD transition, color will not be imparted. Color will not be there for that complex, we can say. So it acts as a colorless. So for example, anhydrous copper sulfate is colorless. Suppose if it is in the hydrated form, if it is in the hydrated form, it will going to be exhibit the blue color. Are you getting my point? Here water acts as a ligand. If there is no ligand, no color. Clear? So one more point here, I want to clarify this point with this point. So let me see these points. The Cu plus, Az plus, Zn plus 2, titanium plus 4, these metal complexes are colorless. See here, suppose these ions which are forming the complex, those complexes are colorless. Why those are colorless? Because see here, these are having the D10 configuration. D10 configuration means that is completely filled d orbital, okay, and have no d electrons, and if there are no free d electrons, means D10 means how it will be like this. Yes or no? And then there is no free d electrons for the transition. So no DD transition, that is DD transition is not possible. DD transition is not possible in case of such a metal complexes, because they have the completely filled d orbital configuration, D10 configuration. So DD transition, there is no d electrons, so no DD transition will going to be takes place, and those acts as a colorless. Here, second, the color of the complex depends upon the ligand. I said you, the color of the complex depends upon the ligand. See here, copper, this one, tetra aqua cuprate. Okay, here this complex, here also 4 ligands are there, here also 4 ligands are there. Here also the central metal atom is copper, here also the central metal atom is, that central metal is copper only. So in these two cases, this complex is exhibiting pale color, while this one exhibiting the deep blue color. Why there is a color variation? Pale blue color will be there, while deep blue color will be there. Why it occurs? Because this amine is somewhat stronger ligand as compared with the aqua. Okay, this is the reason. The color of the complex depends upon the ligand. Which type of the ligand is there, its color will be according to the ligand. And third point, the color of the complex will disappear in absence of the ligand. As I said you, the first point, it's the same. If there is no ligand, the color of the complex will be disappear. Similarly, they have given one more example. Here, this complex is having the ligand, it is a blue color. When you heat, the water is removed, so that the anhydrous, it means no water. Hydrated, hydrous means water is present. Anhydrous Cu plus 2 ions are white in color. White in color in the sense colorless. Okay, if ligand is not there, it acts as a colorless. And the last point, the colors of the complex entities, intensify by the addition of the more number of the strong ligand. Suppose if I am adding more number of the strong ligand, the color will be intensify. It means the color changing will going to be takes place. How it occurs? Let me explain you by taking this example. See here, nickel complex is there. So previously we can say that this nickel complex with the water ligand, where aqua is the ligand, it is green in color. It is green in color. It is treated with ethane 1,2 diamine. There is a formation of this complex which includes the ligand ethane or ethylene diamine or ethane 1,2 diamine. This is pale blue color. First it was green. So we are adding the ligand ethylene diamine, so its color changes to pale blue. Okay. Again for this complex I am adding one more, that is ethane 1,2 diamine. There is a formation of one more complex. It is blue or purple in color. It is blue or purple in color. Again this complex is treated with 1 mole ethane 1,2 diamine. One more time this is added. So there is a formation of this complex which is having the color of violet. This is having the color of violet. It means there is a, just you look at the color, the colors of this complex, the colors of this complex entities are intensify. How those are intensify? By adding the ligands, more number of the strong ligand. We are adding here ethane 1,2 diamine. So addition of the more number of the ligands, stronger ligands, which makes the color of the complex intensify. Okay. So these are the points which are regarding the color of the coordination complex. Here mainly the coordination compounds exhibit the color because of the DD transition. So DD transition is caused by the ligands. In absence of ligand there is no color, in presence of the ligand there will be a color, and certain cases like here like Cu plus, Az plus, those are also colorless because they have completely filled, that is a D10 configuration will be there. So when there is a D10 configuration, no free D electrons for the transition, no DD transition, so the color is not there. I hope so it is clear for you. So this is regarding the color of the coordination complex. So almost we are in the finishing touch of this chapter. Only hardly one more video is needed for the metal carbonyl part, smaller part is left over. Until that whatever I have explained, this is also the that is important bit of the topic regarding the color of the coordination compounds. They will ask regarding the DD transition, how the explain how the DD transition takes place, or what is a DD transition, they will going to ask you, or they are going to give you such a complexes. It is a pale color, it is deep blue color. What is the reason? Because the color depends upon the ligand. Here amine is the stronger ligand, so there is a deep blue color is observed. Or they can give few more, they can ask any question, one mark question on the basis of this. See here, in absence of this is colorless, this is colored, what is the reason, they might be asked. You during that time you have to give the correct statement of the clarity. Clear? So further one more concept is remain, that we will finish, almost we are finishing. So keep watching the video and note down all the points whichever we are explaining, that will be helpful for you people. So we will continue one more session on this chapter, so it will be finished. Until that keep watching the video. Thank you.